mankind has a lifespan. But when that span is complete, it's often not the end, but just the beginning of a whole new existence. From destruction to renovation to transformation, this cycle of life, death, and rebirth happens in amazing places called boneyards. Virtual cities on the sea, offshore oil and gas platforms, and the rigs that drill them are among the largest man-made objects on Earth. Like icebergs, only a small portion appear above the waterline. Designed and built to ride out storms and earthquakes, they can be maintained to last for over 50 years. Most will outlast the deposits of oil and gas they've drilled and sourced. A boneyard of metal giants, waiting for new technology and new deposits to bring them back to life. Some will be cut down and pulled from their moorings, brought ashore to coastal boneyards, where they'll wait to be refurbished and sold to new operators, parted out and reused in new rigs, or cut up for scrap. Today, many are finding new roles. Some are converted into artificial reefs, and in the Gulf of Mexico, they're being reborn as producers of energy, from a source that's abundant and endlessly renewable. Thousands of giant offshore drilling rigs and oil and gas production facilities in the Gulf of Mexico play a crucial role in supplying the energy that keeps America running. But when the oil or natural gas below has been tapped out, or the platform has reached the end of its useful life, its wells must be plugged and the platform removed. And that's why the coastline of the Gulf is dotted with vast boneyards crowded with these hulking structures, like this one at Allison Marine in Amelia, Louisiana. The upper deck's living quarters, helicopter pads, and towering support structures called jackets butt up against each other, awaiting their fate. These structures represent millions of dollars in materials, most of which is steel, and the high price of steel dictates how much of that investment can be recouped. Many will be cut up and sold to scrap brokers in other boneyards. Some will be sold to other operators and returned to work at sea again. Some will be cannibalized for their parts, and still others will be converted to a growing number of alternative uses, a testament to their robust, adaptable designs. When these remarkable machines are towed ashore, they're coming home to the very same places where they were built. It's only fitting because the offshore industry was virtually invented here on the Gulf Coast, with its industrious, creative Cajun community.
There's a tremendous amount of native ingenuity within our facilities. There are no blueprints behind on how to do it. The Cajun ingenuity in the facilities here, we present the problems to our challenges to our people. In turn, they look at what we have, and they end up with a finished product that makes us all very proud for what we do.
In the early 1900s, America had yet to complete the transition to the horseless carriage. Yet wildcatters were already exploring methods of drilling for oil offshore. In the 1940s, drillers from Texas and Oklahoma flocked to oil-rich Louisiana, venturing their drilling rigs into the marshes and shallower waters of the Gulf of Mexico. But they soon realized that drilling offshore was a whole new ballgame.
When you're drilling offshore versus inshore, it just complicates everything because of one, transportation and just logistics. Inshore, you may be spread out over several acres. Offshore, you're confined to that one structure. So whatever levels on that structure, you can put everything, which is storage, all the equipment, everything you need to drill that well has to be right there, are readily accessible through boats.
The early rigs were taking land drilling rigs that you would have in Oklahoma or Texas and place them on small cargo barges, move them out to a location, and you'd place ballast water in the lower hull and have it submerged to the bottom and leveled, and drill wells that way.
Using barges, drillers were limited to shallow depths under 20 feet. After World War II, however, drillers redoubled their efforts buying cheap ex-military equipment from war surplus. One of the many support vessels obtained from surplus boneyards was the Navy's LST, or Landing Ship Tank. The vessel made an ideal support boat for the very first tender platform drilling rig in the Gulf, off Morgan City, Louisiana.
It was a platform which handled the actual hoisting system, and the support equipment was on a LST vessel. They joined the two, and they had living quarters, areas for the equipment, and finally the drilling rig was on a platform.
Although much has changed over the past 50 years, tens of thousands of platforms for both drilling and production facilities have been built using the same basic design: a topsides or deck and a support structure called the jacket.
What we call a jacket is actually a template that sits on the bottom of the Gulf of Mexico. After the jacket is set, piling are driven into the legs of the jacket and stick out about 4 or 5 foot out of the jacket. Then the deck section is set and tied into the pile sections. It can be either a production deck or a drilling deck. Production deck normally has a lot of production equipment. Once the oil or gas comes into it, it can facilitate it and get to land bases or whatever the oil company tends to want to do with it.
The fixed offshore platforms built at Gulf Island Fabrications in Houma, Louisiana, work in up to 900 feet of ocean.
If you were to take a ride offshore, you'd only see about 10% of what we actually fabricate here. The part you see is the big decks, the jackets. The hard work that we put into the facilities, in some respect, is underwater. It's deep sixth. You can see the size of the platform behind me. And again, less than 10% of that will be above water.
The jacket is made of giant steel pipe sections referred to as tubular members.
We typically take a flat piece of steel. Our mills roll them, we weld them, we then join those sections together, and you end up with a 300 to 400 foot can or a jacket leg.
Much of the cutting and welding at Gulf Island is automated. As the braces and legs are welded together, the jacket begins to take its final form. The U.S. Minerals Management Service requires each component of the assembly to be ID'd with a tracking number.
If they get a failure offshore, they have to be able to go back and check if it was a materials aspect, if it was a welding aspect, or what, God forbid, any kind of catastrophe that would happen. But they can actually go back and track each weld and each piece of pipe that we use.
It's one big machine here. What you see here is it went through the process of our rolling mills to our cutting tables, to our brace cutting facilities, to our welding facilities, into the completed structure you see behind me.
Although engineered to withstand incredible stresses at sea, the jacket is vulnerable to stress when it is loaded onto the barge that will transport it offshore. The giants are moved by Mammut transporters, remote-controlled flatbed vehicles with so many tandem axles, they look like centipedes on roller skates.
The capability of each transporter is 200-ton capacity per transporter. We currently own 6 transporters, which equates to 1,200 tons of lifting capacity.
To prevent stress on the jacket, the loadout must proceed slowly and methodically. Even if nothing goes wrong, 8 to 15 hours for the job is typical. The jacket is pulled onto a ballasted barge with hydraulic jacks called strand jacks. So great is the stress that the steel cable in the operation will never be used again. It goes to the boneyard to be cut up, melted down, and recycled. Finally, the jacket is secured on the barge and bound for its new home. Years from now, after the jacket has outlived its time in the Gulf, it may come back to this yard in Houma, Louisiana, or another nearby. What happens to it next depends on its structural condition and usefulness.
We do a lot of refurbishment work. They might bring in a jacket that was set in 200 foot of water. They might cut some out, make it for 140 foot of water or different water depths. They can also add to it, make it for deeper water.
But many of the platforms in the boneyard won't be leaving it again until they've been cut up in pieces. Welders dice up the structures, cutting the metal into sections. The sections are craned over to another part of the yard where they're cut into smaller pieces, then loaded onto trucks with a magnet grapple. The pieces may be hauled to Southern Scrap in New Orleans, further processed and barged up the Mississippi. Scrap brokers sell it to steel mills, where it is melted down and made into new steel.
The mills will actually cast the steel again to be reprocessed back into the next project we have.
Two offshore facilities that escaped the cutting torch sit just a few miles upriver from the Gulf at Morgan City, Louisiana. One is a small production platform. The other is an historic drilling rig known as the Mr. Charlie. Named for one of its investors, it was the world's first submersible drilling rig. The Mr. Charlie drilled its first well in 1954, the first of more than 200 in its remarkable 32-year career.
When the Mr. Charlie went out, it was the first movable rig, so it was a rig that you could use over and over again. So it just revolutionized the whole industry because you weren't spending $250,000 building a platform for a one-time use.
The Mr. Charlie was the brainchild of Alden J. Doc Laborde, a former naval architect.
That there would be a better way to do this was obvious to anyone out there, so there was no great stroke of genius. But I knew a little about the water and the ocean and waves and things that I don't think these Oklahoma drillers had much idea about.
In spite of all the skeptics who said it would never work, the rig made a huge strike for Shell Oil on its first drilling job. Built for $2 million and backed by the Murphy Oil Company, the Mr. Charlie had accommodations for a crew of 58 and everything else necessary for drilling. The barge was sunk on site, using the weight of the water to help anchor it in place.
It was the first step into the deeper water, and it was excellent. You had a lower and upper hull and extension stability legs, and it had what's called a keyway, where you would drill not cantilevered off the side of the vessel, but within the vessel.
But by 1986, the Mr. Charlie was outdated. Drillers were using more advanced and efficient technology and moving into greater depths. In the early 90s, Doc Laborde's company, Ocean Drilling and Exploration, ODECO, decided to retire the rig and cut it up for scrap.
I just couldn't see any reason to cut up that piece of history.
Through Virgil Allen's efforts, money was raised to buy the Mr. Charlie and preserve it for a new life. Today, companies bring their prospective offshore hires to work, eat, and sleep on board for a 14-day trial. It's a 24/7 hands-on experience on a working rig. Some may decide the life is not what they expected and get off. For others, the Mr. Charlie opens up a whole new world. But even if it had been scrapped, in the continuing cycle of offshore life, the Mr. Charlie's steel may well have ended up in even newer and greater rigs and platforms. Every offshore oil and gas structure is surrounded by potential dangers. Storms, rogue waves, payload stress, accidental collisions from passing ships, and corrosion are just a few of the forces that can mean a premature trip to the boneyard. Following criteria established by the Minerals Management Service and the American Petroleum Institute, the design of each platform must allow for the stresses and hazards particular to its geographic location. Platform Gale, for example, is one of more than 33 structures off the coast of California where critical design includes the ability to survive earthquakes.
Platform Gale is a drilling and production platform. We're about 10 miles from the coast of California. We have survived earthquakes on the platform without any major problems. They're fairly rigid. It's like being on the end of a whip when you've got this structure that's 750 foot tall. It wants to sway quite violently at the surface.
Owned by the independent oil company Veneco, Platform Gale is 900 feet tall, most of which is underwater. The jacket is anchored in place by steel pilings hammered several hundred feet into the seafloor.